increase the amount we know about our solar system and to find life, that there will be an ecosystem of constellations in space that interact with each other based on their value chain relationships.
Hello and welcome to another episode of the Accelerometer. I'm Dr. Matthew Merman, CEO and founder of Anarchy. Today we have Geffen, the founder and CEO of a company called Skyline Celestial that's trying to mass produce satellites. I'm here in his workshop where they're actually experimenting on figuring out how to send these things to space and construct them cheaply. They've got a huge number of really fascinating historical and still important cameras just lying around here, and I'm a little bit curious to find out why and explain to you guys what's going on here.
This is Skyline Celestial. This is our laboratory, office, startup company headquarters, and development center for experimental digital and film projects. You'll see all kinds of things. This kind of thing, for example, not set up yet, but this is a combustion chamber from the Virgin Orbit Launcher 1 rocket. As far as I know, we have the only Launcher 1 rocket engines left in the world. This is the cinema product CP16 film camera, which I will turn on, and you'll see it's pretty quiet. And can only record for 11 minutes before you have to replace film reels, which are very expensive. This is the other 16mm camera. It's the Eclair ACL. It's a very nice and compact film camera. Extremely convenient to take around with you. I've just rigged it up with some stuff here.
Into cameras.
I don't know. I guess I was always into filmmaking. My uncle's a director as well. But that's not even really the reason. I always kind of wanted to make movies. And at some point I became very interested in I'm a space person. I became very interested in the space history of photographing it. Because the way I see it, you send a mission to outer space. You're going to bring back something, right? And what are you going to bring back? Well, a lot of people care only about science, which often for them means proving their PhD thesis from 30 years ago correct, which is great. I mean, science is amazing, but also, at the same time, I feel like the picture, which means something to 7 billion people, is more important than the science, which means something to 7,000 planetary scientists. And I think even if you walked around a space conference and asked people, what are the Apollo astronauts, what experiments did they do on the moon? Very few people could tell you. You ask them if they've seen the picture of Buzz Aldrin holding the flag, every single human being has seen that picture unless they've lived under a rock. So science is important, but the pictures and the videos, they inspire all of mankind. Yeah, well, Skyline's here to really, the phrase, so many phrases are overused in this industry. Among them, the phrases, making space for everyone, democratize space, blah, blah, blah. Everyone uses them. That's why Skyline's slogan is making space available for everyone by democratizing space to break space down to Earth, to make space a better place, to improve life on Earth from space. Just all the slogans combined. No, but seriously.
Why not make space better for the moon people?
Well, the moon people are important. People don't care about them enough.
It's true.
It's true.
I mean, there's like one man, though, so
yeah,
it's not enough.
I guess not. But he is a minority, We need to
or a majority
is on the moon.
Planet.
It's on his own planet. That's true.
In the set of people, maybe a minority, but we also don't know that because there could be people on planets
that's true.
Much further away.
Besides, what about the man on the other side of the moon? No one.
I haven't seen him. Only one person could have seen him.
Only one person could have seen him, exactly.
That we know of.
That we know of. Well, that's the thing, right? We're here so that space will be for more than just a few people. And the way that I really became inspired to do this was going way back to when I was a kid. I won't forget the time I went to the Chicago Museum of Science and Industry. I was like 5 years old, and I had this book about the Apollo program. And there was this little diagram of the Saturn V. And I go to the museum, and then I see the spaceship. I see the Apollo 8 capsule, the first spacecraft ever to carry people to fly to the moon. And it was just this insane moment of realizing this is the thing from the book, and this thing is actually, it's flown to the moon. And ever since then, I was obsessed. Well, actually, even before that, but that's a moment that's easy to remember all these years later. And I first wanted to build a CubeSat, which is a miniaturized form factor of satellite, kind of a kind of like computers have mini ATX, ITX, blah, blah, blah. They have all these motherboard form factors and case form factors. CubeSats are a form factor for satellites. So I wanted to build a CubeSat for the first time when I was a 10-year-old, actually. Why? Why did I want to make a satellite? Well, because I wanted to be a spy as a 10-year-old, and every spy needs a spy satellite. But that's how I started learning about the existence of these small miniaturized things that could promise to maybe one day make space actually affordable for kids who want to launch something to space. And that, since that has been my driving motivation. I want to live in a world where like kids who are like, I love space, can like have their own satellite and explore with it. That's what I want to work towards.
What do you think kids would do with satellites? What did you want to do as a kid if you could launch a satellite?
Well, I wanted to put a Nerf gun on it and shoot people from space, but that may not be practical.
I mean, I think like space laser tag, space Nerf tag,
right?
Like, I think people would pay a lot of money.
Oh, absolutely. There's so many things. I mean, even just like logging in on after school to your bedroom, instead of opening like some video game, opening your console and like looking at the live stream from your satellite at the Earth and then pointing it around in space. Wouldn't that be the coolest thing ever?
I mean, think about it. Like, if you could actually create a $5,000 satellite, get it up to space cheaply, you could, in theory, give people their own satellites so that they could play like satellite laser tag.
Absolutely.
Or even if they're not going up themselves, like
they could play satellite laser tag, and they could do little orbital maneuvers, take photos of each other's spacecraft. So many things you could do.
Could you fly to other planets?
Eventually. That's tricky. But I mean, if you had a solar sail, yeah, probably. But you need to, for a world where kids fly stuff to other planets, you need very advanced automated maneuver planning software for solar sails.
I feel like parents probably aren't going to want that. I feel like there's going to be a lot of, maybe predators on other planets.
Yeah, I mean, the floating jellyfish on Jupiter, they're very predatory.
Yeah.
It's interesting how that concept originates from a certain story written by Arthur C. Clarke called A Meeting with Medusa, and then in
The jellyfish,
the space jellyfish. Carl Sagan adopted the floaters, the Medusae, from Clarke's story in his Cosmos series, which was a nonfiction. And then from then on, it's become like the standard depiction of life on Jupiter. But yeah, I mean, honestly, like imagine there's so much stuff I've wanted to do on other planets in terms of science. Like, one thing we want to do is send a probe to Enceladus, because Enceladus has these, it's an ice moon. There's an ocean under the ice. And in the ocean, we know there's complex organic molecules because Cassini actually flew through the geysers that come out of the ice, and it sampled the water. But Cassini didn't have the instrumentation to detect life. That's why we need to send something there to see if there is life in those geysers. Who knows? That's just one of the things that can be possible scientifically, but also commercially, when you have the ability to send stuff to space on a whim in a matter of weeks, perhaps, and for no more than an expensive Apple computer. This is a Russian 35mm film camera, and German Titov, who was the second man in space in 1961 or 2, he took this thing into space with him, not this actual one, a similar model, slightly different. And he took the first movie ever taken from space on 35mm film. This type of camera is a very important and often neglected part of space history, and I'll even demonstrate it for you. It's pretty loud. Maybe the audio will pick it up.
Oh, definitely.
Yeah. There we go. And this is another CP16, a slightly different model. And this is one that absolutely did not come working and has required quite a lot of work to even get it anywhere near like condition where I can use it. It was the guy who owned it had it in a foam case, and the foam case melted into it. And so I had to scrape off all the like half melted foam. And also the drive belt was corroded, and also the light sensors broken. There was still a ton of work to do on this one, but this is a project camera for me.
So tell me about the first time you worked on a satellite.
Absolutely. I was a 16-year-old. I hated school. I felt very unsure of what I wanted to do in the world. And I decided that I was done with school, so I dropped out of school when I was 16. And, this was a bit scary for me, especially as a guy with, a family who's all like PhDs, right? I'm going to be the high school dropout in the family. And I decided if I'm going to drop out of school, I'm going to need to follow like my passion to a point where I do something that no one else is crazy enough to do, right? You know what I mean? Like, I could try to build up a GitHub repository, but some kid in India is going to do it 100 times better than me, right? I'm never going to be the best at that. But what can I do that no one is crazy enough to try? And I thought satellites, because that's something I've been wanting to do, right, since I was 10 years old. And of course, back then I had a bit frivolous reasons for doing it, but the passion to send something to space was real. The reasons were always changing, but the passion was the real reason. In other words, space, not spy. The satellite and not the spy was the thing that was pulling me there. Anyway, I decided I wanted to launch a CubeSat by the time I turned 18, or I guess before I turned 19. And for a while, I didn't know how to approach that, because where do you even start with that? Where do you get the funding? Where do you do all that? And eventually, I found out that there was a laboratory not far from where I lived. It was actually working on CubeSats. And so I joined that lab to kind of learn the trade and learn how it was done. And so I joined this laboratory and started working on one of their CubeSats. They kind of took me in. And for a while, I didn't quite know what to do. It was very much throw you in the water and you'll figure something out, right? But that's the best way to do it. And so that really pushed me to kind of learn a lot of things on my own, because I really didn't know very much at the time, right? So much of the stuff I just had to learn by reading papers and studies and asking people and all that. Then when I was 17, I started thinking about the Enceladus mission, and I got invited to some conference in China and flew to China to present this mission. I was the only high schooler there at the time. High schooler, I wasn't technically in school, was I? I was only 17-year-old there. Was when I decided I needed to start this company, because I was in that lab, and when I was about 18 years old, 18 and a half, we launched a satellite, which is still up there today as far as I know. Maybe it's gone by now, but it did work. We got images from it. I saw how problematic the industry was. So this lab, we were buying components from a company in the Netherlands, and their entry-level satellite, not even the one we launched. The one we launched was an imaging satellite. Their entry-level. One's just a box that goes up there and goes beep, beep. It can't even turn to look somewhere. It doesn't have a camera. It doesn't have any sensors. It's just a box that says hi from space. That costs $70,000.
Why would you want that?
I'm not entirely sure. Just for the fun of sending them into space. But at least put something on it, right?
Yeah.
At least put one little camera, but no. And I'm like, why is this costing $7,000? Why is it like this? Why is this computer that is running a processor architecture from 2009, why is it $4,000 when the Raspberry Pi is more powerful than it, right? And I was like, at first I was being told all these things. I was told, well, the reason it's because it's radiation hardened, it's because blah, blah, blah. And I'm like, wait a second, no, it's not. Like, it's true that some expensive spacecraft use radiation hardened satellite processors, but say the Bay Rad 750, which is the processor they use on the Curiosity rover, that doesn't cost $4,000. It costs $250,000. And that is the highest reliability space processor in the world. The thing we were using, it used a normal processor that's used in like watches and like ordinary devices. There was nothing space grade about it. It was just designed for the CubeSat form factor. There was no technical reason for it to be that expensive. And I'm like, I guess no one's going to change this unless I do. As Dr. Seuss said in the Lorax, unless someone like you cares a whole awful lot, nothing is going to get better. It's not. So I resolved I'm going to start a space company. And came to San Francisco. I actually landed here the day of my 18th birthday. This was after the satellite was already finished. The one I built before, right, as a high schooler, it was already finished, but not launched yet. It was still like a waiting launch. Ended up getting launched a few months afterwards. Yeah, I came to San Francisco and decided to start this company. And happily ever after. Well, no. It was a long, long journey. It's been years now, but it took me a while to even coalesce my idea into, something concrete. It took me a while to learn how the venture capital ecosystem works. It took me a while to learn how to talk to these people. It took me a while to learn how, the space industry works. It was still so much learning left to be done, even after I got here, that, maybe I'd watched The Social Networks too many times as an 18-year-old, right? I'm like, oh, you come to Silicon Valley and within 6 months you're going to be living in some party house with like billions of dollars rolling in your coffers,
That's false.
Well, maybe you're for Facebook. To be fair, everyone at the time Facebook was the hottest startups people had seen in a decade at that point. So half a decade. So I don't know. I am very happy. I am not Facebook though. I do not want to, make a fortune from selling ads to people. That's not what brings me joy every day. Although it is kind of funny how in the last few months or years, the popularities of Musk versus Zuckerberg have kind of been inverted. When I got here, Zuck was definitely Lizard Man.
So I mean, Zuck is now your family guy.
Yeah, right now he's like the cool, chill family dude, and Musk is like the angsty Twitter guy. And back in the day, Musk was like the cool kid, and Zuck was the inhuman robot, right? Yeah, there was this meme about people from the future sending back a Terminator to kill young Mark Zuckerberg before he invents Facebook. But then the Terminator grabs him, and then Zuckerberg like blinks sideways, and then turns his head like this, and then throws the Terminator across the room. This is the Photosonics 10B, which is the world's fastest, and in fact the fastest ever made in history, 70 millimeter camera. So this thing can shoot 70 millimeter like IMAX film at 360 frames per second. And no one has ever made one that can do it faster than this. In fact, even Christopher Nolan, when he had to shoot slow motion for Oppenheimer, he had to use a 35 millimeter high-speed camera because he didn't have one of these. Now, for good reason. It's a gigantic thing. It requires a 3-phase 208-volt power supply to even run it. It's like a 2-horsepower motor in here. It's like a car motor. And if you come and look inside, you can see here, it's not a regular camera. It's actually a rotating prism camera. So these wheels like spin. And then come around here. Yeah, let's just see. Now you can come see it from the other side as well. If you look from here, you can see the prism spinning. So basically, in this camera, the film is continuously running through the thing, and the way the frames are aligned is by this rotating prism that spins increasingly fast as you run the camera. And this is going to be a whole lot of work. Like you can see right now, this is not in good condition. There's not even a lens. There's no magazine yet. So many things are missing. There's going to be 3 steps to make this work again, which is the cosmetic repair, the lubrication, the cleaning, then the electrical stuff. I have to rebuild the control box, get the motor spinning, get the thing running, and then comes the hard part, which is the perforations on 70 millimeter film have changed, and the film that this was made to use has slightly different holes than the ones that they use today. So I'm going to have to take out the wheels, machine new ones, and put them back in, and then get it to run, which is something that no one until me has been crazy enough to try. Like, people think, like, this is a crazy thing to do. Like, no one has been insane enough to attempt this, but I'm going to attempt it. And when I'm done, this will be the fastest 70 millimeter camera on the planet that actually can be used.
What do you plan on shooting with it?
Glad you asked. So I've been working with the people who shoot the Starship launches down at Boca Chica, and we're going to produce some very, very nice footage of it. Like, if you've seen Oppenheimer and IMAX, that's what you can expect from the Starship launch, except better, because the slow motion there was 35, and this is 70. So we're going to record rocket launches with it. I just wanted to show you these film stocks here. This is 16 millimeter infrared film. We're going to recreate the Harkonnen planet effect from Dune on film, which even they were crazy enough to do. Dune is interesting. One of the reasons it looks so good is because they shot digitally, but then they actually printed the film to celluloid film, then scanned it back, and then projected it. So you kind of get that effect without having to carry around a big film camera everywhere. But we're going to actually shoot on celluloid directly. This is Ektachrome, which is the film that was used during the Apollo program missions. This is
Special.
So Ektachrome is special for several reasons. It is Kodak's, I believe, last remaining color reversal film. So what that means is that unlike a normal film, which is a negative film, in other words, when you process it, you get back negatives, this is a film where you develop it, the image is positive, so you can immediately look at it and project it. So you can just develop this and immediately run it through a projector. So this was very popular back in, like, say, the Super 8 days, right? Because, home movie makers in the 80s, they'd shoot Super 8, and then they develop it, and then they'd immediately want to project it. You're not going to go into a lab and start making prints, because when you shoot on negative film, you have to take it to a lab, and then the lab has to run it through a machine that takes your roll of negative film and then puts light through it onto a second roll of film, and then projects onto that, and that negative film now gets a positive image from the negative. It's a whole process. It's expensive. It's tricky. This was way easier. The Apollo people also liked using it. I'm not sure why they chose it, but it's gorgeous. It is my favorite film stock in terms of how it looks. It's based on the legendary Kodachrome. Sadly, no longer exists. Actually, it does exist. It just can't be developed anymore.
What was the hardest thing about learning about the ecosystem?
Good question.
Thing about the hard thing.
The hard thing about the hard things. I mean, it's a good question. All kinds of parts to it, really. Part of it was learning a bit about how space companies work, other ones. I visited a lot of them. I visited Planet. I visited NASA. I visited, Astronus. I visited all kinds of other companies. Just learning what kind of things they worry about was important to know, right? And also learning things about the industry that are not necessarily stuff that apply to your average Y Combinator blitz scale company. Because a lot of the stuff you read on Hacker News or YC Startup School, wherever they redirect you, right, is pretty useless for space companies, especially ones like mine, which, as I have said in the past, it's like I always said, and this was kind of weird. It's not weird now, but it was weird when I came here. I said to people, like, I'm not interested in selling a service. I'm interested in making stuff. And that's what sets me apart from the other ones, right? Like Planet Labs has, they're great at selling images. They're not interested in, and that's not what their platform is for, a general purpose Macintosh for space, right? That's not what they do. And I think that's kind of a shame, right? We kind of live in the world where Apple went on stage in 1984 and the Mac said hello. And at the end, there's a little asterisk and it says, actually, you cannot buy the Macintosh. You can only, rent time on it from Apple HQ, but it's never leaving our offices. And I'm like, what a shame, right? No personal computers in this world. And that's the revolution we missed 10 years ago when companies like Planet and Spire Global started to apply. Like Spire Global was originally called ArduSat because they literally were putting Arduinos in space. They had similar views, but they had to do selling services at the time because in 2010, that was the only way you could fund a company like that, which makes sense. But when I came here, I told people I don't want to be Uber, I want to be Tesla. And I think time has proven me right. Tesla is more profitable than Uber. And also, who would you rather be? The guys who come up with better ways to improve the rating interface on your little mobile app? Or do you want to be the guys who, build cars and make motors? Uber doesn't even make their flying cars anymore, right? They shut down ADG. They spun it off.
I did not even know they had a flying car division.
They used to. I went. It's actually fun fact. It's headquartered right across from Gusto and the Dog Patch, where current offices of Astronus. They used to be the Uber ATG offices, where they had a big mock-up of a flying car in their front warehouse. I actually have visited that place twice now. Once when it was Uber and once when it was Astronus. I am very happy it is Astronus now. As much as I like flying cars, they never actually flew anything. It was just a meme for the investors, I don't know why they spent so much money on nothing for that. But anyway, yeah, I told people, and at first, this was a controversial thing to say. I don't want to be the Uber. I want to be the Tesla. I think people have started to realize that the ecosystem of aerospace and defense is different from the ecosystem of Salesforce and Airbnb. You cannot run a aerospace contractor like you run Stripe. And as much as Stripe is the golden boy, and I love Stripe, I've done a lot of good things. I love Stripe Press, right? But that's just not the model for running a space company. And frankly, if you try to run a space company like that, you will go the way of the companies that are now dead. There are quite a few startups that try to be too hypey for investors, and rather than operating alongside perhaps more traditional methods of systems development and engineering management, and they're not around anymore. But that's not to say that running an aerospace company this way is easy. It is not. This is a very nice vacuum chamber. We got this on Craigslist. And now, how did we get this on Craigslist? Well, a friend of mine found this. It was being sold for relatively inexpensively on Craigslist for all the stuff it came with. It came with the turbomolecular pump, the roughing pump, and the gate valves, and the gauges, and all that. And it was only several months later, while we were trying to get this to actually work, that I'm like, let's find out who built this. And maybe they can help us get it work because we were having some trouble with it back then. And what we use this for, right, is for testing satellites. So we put the satellite in here, and then this becomes a thermal vacuum chamber where we have a light source that simulates the sun. And then we can also have a cold plate that can cool it down to simulate the cold, harsh vacuum of space. And then, of course, the air gets pumped out. And so then we can do all kinds of things. We can simulate how these satellites react when they're exposed to space and are exposed to cycles of hot and cold with no air around them. And we can see if they outgas, because like plastics, for example, in a vacuum might have bubbles that start to pop inside the plastic and release all kinds of things. We can make sure that doesn't happen, or alternatively, if we know it's going to happen, we can have it be done here so it doesn't happen in space. So that's what this is for. It's a space simulator. Now, I had known that this was used to test the Southern Stars, Southern Skies, SkySat CubeSat back in like 10 years ago.
What's a CubeSat?
Glad you asked. A CubeSat is a small modular form factor of satellite. So long story short is back in the 90s, two Stanford guys, or actually one from Cal Poly, they were working on student satellite projects, and they're like, what if there was a single unified form factor for satellites? The same way with PC cases. We have, mini ITX or ATX or whatever, and you have a case and you have motherboards and you have parts that fit in it based on a particular form factor. What if we had that for satellites? And so they said, let's have a 10 by 10 by 10 centimeter cubical satellites. You can do in different sizes. So you can have 1U, and that's a cube, and then you have 2U, and you have 3U, and you could have 6U, and you can have 16U. And then those things can just share the same components because they just fit in the stack. And they can be launched together in bundles. And that's what a CubeSat is.
So now that presumably you're funded,
Yeah.
what is your next milestone?
Good question. So right now, our next milestone is working with our first customer on a first customer flight. So we're working right now on a mission for them to be launched later this year, hopefully Q3 2024. That will be our very first ever customer mission to launch our platform into space with their payload. And so ideally, that will give our system what's called in the industry flight heritage, meaning it has proven its worth in space, and not just flight heritage, but flight heritage with a paying customer payload. So that is what we're working on right now. And concurrently, we're also working on some other missions for later.
Can you talk about what the payload is?
I could say it is about GPUs in space, which is something that I'm interested in myself. That's something I would be talking about even if we didn't have this company as our payload. So I think GPUs in space are very important. And that's why even without this company's payload, our own onboard computer has a little Google TPU on it, because we think that there's a lot that you can do once you process the data in space. So let me see if I can remember the chart I made for this back in the day. But what we believe in is that there will be an ecosystem of constellations in space that interact with each other based on their value chain relationships. In other words, multiple companies, which are not necessarily space companies, just like Amazon now runs one of the largest ground station networks, and Microsoft has an Azure space division. And I mean, Google has been doing space-related stuff for quite a while. Non-space companies are becoming space companies. And I think that follows in many ways what happened in the computer era. If in the 1950s, you had gone up to the guy who runs a deli around the corner, and you had told him, "Mister, you should buy a computer for your deli," he would have been, "What? I sell like drinks. Why would I need a room-sized math machine that computes ballistic missile trajectories for the Army? I sell food and drinks." But today, there isn't one of them that doesn't have that annoying square thing that asks you for a tip even when there's no service. They all have a computer in their cash register and in multiple other places as well in the shop. So I think the idea is that every company can become a space company. Now, what does that look like? That can look like all kinds of things. So you have, for example, Constellation A. Constellation A is owned by, say, what's her name? Digital Globe, now part of Maxar, or say Planet. What they do is they take pictures. They specialize in imaging, and they have big sensors. They take photos of the Earth. Now, traditionally, they'd wait a few hours and then downlink them down to Earth, and then they'd burst server that processes them. But now, instead, these pictures are, with almost no latency, transferred to another constellation, which is the Orbital Data Center. And that's owned by a different company, say IBM, the IBM Orbital Data Center. And that thing has a lot of GPUs in space. And that takes requests from all kinds of satellite constellations for low latency image processing. Now the GPUs on that space data center, they process the images and they can immediately tell what's going on in one picture. So for example, I don't know, say they detect a fire in one image, or say they detect a certain number of cars in the parking lot of a Walmart, or say they detect an oil spill in the Saudi Arabian Gulf. Well, they detect the oil spill in the Saudi Arabian Gulf. That becomes an insight, a piece of data. And that piece of data, there's an oil spill in the Saudi Arabian Gulf, I can explain that to you in 5 words, not in a picture that takes several hundred megabytes. So actually, it's more like, they say a picture is worth 1,000 words, but in this case, getting the words out of the picture is much more important because the words take up so much less space. So,
and it's the communication bandwidth that's expensive here, or?
Correct. And also the latency.
Yeah.
So, a picture is worth 1,000 words is traditionally used to express how big a picture is, but actually here it's meant to show how small it is. 1,000 words, that's what? 1 kilobyte? That's nothing. So now you have these insights, and now they get transmitted to another constellation, and say that one is owned by Jane Street. And what they do is high-frequency trading in space, where they have lossless laser links between different satellites so that you have completely low-latency communication. Forget even low-latency fiber optics, you are doing free space optics. And then these guys, the Planet satellite took a picture of the oil spill in the Saudi Arabian Gulf. The IBM Orbital Data Center said, this is an oil spill in the Saudi Arabian Gulf. The Jane Street thing says, let's make a trade on Saudi Aramco before they know it. And now they do. And that is the value chain relationship of constellations in orbit when every company can be a space company.
So what do you plan on doing yourself with your lasers? Or not your lasers, sorry. With
My satellites.
I mean, there are also some lasers that go on and...
Yeah, I do want to build laser systems to enable...
Space lasers.
Space lasers. We are making the Jewish space laser. That's my goal. I even have I'll show you the button. I have the button for it. They've entrusted me with it. I'm a very, high-ranking member. But, yeah, I want to make, frankly, the Ford Model T for small satellites. Nothing more, nothing less. And what I want to do with that is to, in my personal desire, is to increase the amount we know about our solar system and to find life. That's what motivates me a lot, right? I want to send missions to all the planets, not just to Mars, but to Saturn and to the moons of Jupiter, and to Uranus, and to Neptune, and to Pluto, and Eris, which we've never been to. Never been to Eris. That's what motivates me. Now, at the same time, as I said, I want to make it possible for the next 1,000 space startups to build their businesses. So now, if you're starting a company, you can go to Y Combinator, and with the money you raise from Y Combinator, just that, nothing more, you'll be able to launch a demonstration satellite to orbit. And then with your seed round, you'll be able to launch 10. And then by the time you raise Series A, you'll have a whole constellation up there. And that's something that today you need to raise tens and tens of millions of dollars to do, if not hundreds. That is what we are for, to enable the next 1,000, 10,000 space companies. So this is a CubeSat. This is a 1.5 view, so it's about 150 millimeters in height. It's very small. You can see I can hold it in my hand. I haven't attached the solar cells to this yet, so that's why I'm holding it like this, right? If I had the cells on, it would be a lot more expensive and fragile. But this is our main board, and here I'll show it to you a bit closer up. So right now, this wee thing is the EPS. So the batteries can be attached here at the bottom, and then this is the power routing system that connects to the solar panels, and then here is actually a pluggable module that can be removed, and let me remove it. This is the computer. This is our Linux flight computer that is several times more powerful than most, microcontrollers that power satellites. So the first satellite I worked on, back when I was a teenager, we were using a ARM9 400 megahertz processor with an architecture from about 2009. And this thing is much faster than that. It even has a slot here for a Google Coral TPU, so you can even try to run image processing models on it in space. And then that just plugs into here. So now, traditionally, in CubeSats and in satellites in general, these have all been separate subsystems. So you'd have had a big, block for your power system and another big block for your computer and another big block for your radio. And here there's another slot for a radio, which is not here right now. But here you just plug a radio and suddenly the entire system, you put the batteries down here, the entire satellite becomes a modular satellite on a board. And that fits into there. And now that's how you are able to have a satellite that saves both space and cost while giving you more power. We took the innovations that people have been using to make phones and smartwatches and whatever cheaper and smaller over the last, 15 years. And we applied them to satellites, which few people had done. So to this day, most commercial satellite manufacturers in Europe and other places, they still sell you the same product that came out like 15 years ago. In other words, like imagine if Apple were still selling you the iPhone 3G. That is basically the state of the European commercial satellite industry. And then the rest of the American nano satellite industry, well, they don't really make stuff for the individual or for startups. They focus on larger nanosats, like stuff like this big that costs about $2-3 million that's meant for government and military applications. And what we do is we make cheap satellites that cost as much as a car, perhaps, not as much as a private jet. And eventually it'll cost as much as an Apple computer, an expensive Apple computer.
Let's dive into how you create these satellites a little bit. How exactly do you go about building a $5,000 satellite?
Good question. Well, the good news is that chip makers, and by chip makers, I'm not really talking about TSMC as much as I'm talking about the people who make the IP for them, like ST or Analog Devices or TI. Chip makers have put a lot of work into putting tons of functionality that we could have only dreamed of in the past into extremely low cost and extremely simple to use packages. So now, many capabilities that in the past would have required big boxes and relays and towers are now doable with this. So
the chip was the primary cost before.
Not necessarily, but it enables you to put more things into less space and to, when you reduce the size, weight, and power, everything goes down, not to mention the launch cost as the mass goes down. In the last decade and a half, we've built a ton of miniaturized consumer electronics, beginning with smartphones. We had laptops, tablets, smartwatches. Nowadays, we have smart coffee makers, juiceros, whatever.
Smart boxes.
So today, chips are a dime a dozen. And that is what makes it so easy to make spacecraft better. So many capabilities, like advanced RF, like high-performance computing, like processing of images. These are now available in inexpensive chips that can be integrated into small boards that reduce what's called SWaP, size, weight, and power. If you reduce that, you reduce the cost, you reduce the mass, launch cost to orbit, all that combined. We can use the same techniques we've been using for decades to make smartphones smaller, cheaper, and more powerful for satellites. But why aren't we? Well, because the rest of the space industry, all the companies in Europe, for example, I am afraid I don't have the highest opinion of the European private space industry, or public one even. But they're like, oh, this is the way we've always done it. This is the way it's always been. Such is so, a decade ago, Arianespace, the European space rocket manufacturer, they were like, oh, reusability is just a fantasy. It's not real. SpaceX is just a meme. It's not going to happen. Starship is science fiction. It'll never fly. They were saying that. And you know what? Today, Ariane 5, Arianespace's flagship rocket, doesn't even fly anymore. And Ariane 6 has been delayed so far that Europe doesn't have any working rockets anymore. Except maybe Vega, but Vega explodes every time these days. Their quality control has gone completely off the charts. Even Chinese rockets do better than, maybe soon North Korean rockets will do better than Vega. I apologize. No offense to our European audiences. I just, you gotta not be content with the way things are. People have too long said, this is the way we're used to doing it. But that's not to say there isn't anything to learn, yes? That's not to say there isn't anything to, they shouldn't be listened to. However, it's simply that, as Arthur C. Clarke said, when a distinguished but elderly scientist states that something is possible, he is almost certainly right. When he states that something is impossible, he is very probably wrong. That's Clarke's first law.
I want to put a distinguished elderly scientist on acid, and then the things that we're going to get in this reality are going to be amazing.
Right. Well, bring back Clarke from the grave and ask him what's the law about when a distinguished but elderly scientist goes on acid. Yeah. By the way, the second law is the only way to discover the limits of the possible is to push a little way past them into the impossible, which is what we try to do here. A little bit. Most spacecraft today aren't expensive necessarily because of the technical difficulty in making their components. Components are expensive because they're made by legacy companies in low volumes, and it becomes a self-reinforcing catch-22. You make the satellites in low volumes, you sell maybe 5 of them a year, and because you sell only 5 a year, they have to cost hundreds of thousands of dollars each, even for the cube that goes beep beep and does nothing, much less for the ones that actually are useful, which would be millions. That's just the way it is for them. But what if you sell 500 satellites a year? Well, catch-22, you have to build the $5,000 satellite first before you can sell 500 satellites a year. And that's what we're here to do. It's the answer to a lot of these problems is mass manufacturing and utilization of modern technologies and chips and modern manufacturing techniques for these. Make them like we make drones, like we make phones, like we make laptops.
Yeah. Thank you very much for coming.
My pleasure. It has really been a pleasure. Thank you. It absolutely has. This is a very fun day.